Hey folks, this video is about the atom. First of all, to talk about the atom, we need to talk about what matter is. Matter is anything that has mass and takes up space. So the old saying is, you have mass and you occupy space, so you definitely matter. Basically, everything in the universe that isn't energy is matter. It's usually in the form of something we can see or touch or feel, but not always. Uh, so a long time ago, even before I was born, about 440 BC, Democritus, a Greek philosopher, sat around in his white robe near the Parthenon, I assume, and just kind of thought to himself, how many times can I cut something in half? So he thought, well, if I take like this chunk of rock and I cut it in half, and then I cut a piece of that in half, then I cut a piece of that in half, how far can I go? Uh, and he wasn't really sure, but he eventually came to the conclusion that you hit a point where you can't cut it in half anymore. And that point is what he called atomos, which means a particle that cannot be divided. So really, he was the first one to think of what atoms were. He thought if you cut something in half all the way down, you get down to a very tiny piece that you can't see that would be an atom. And there was another philosopher at the time named Aristotle who totally disagreed with him. He said, well, we can't see atoms, so they don't exist, right? These were both very good theories at the time because they didn't have a lot of scientific evidence to back them up. They were mostly just thought experiments. But eventually, over multiple years and a lot of testing, we found that Democritus was a lot more right than Aristotle was. So much later, we had a guy named John Dalton, and he came up with the atomic theory, or the original atomic theory. And he had a lot of things to say about atoms, but two of the more important things were that all atoms of an element are identical. So every hydrogen atom in the world is exactly the same. Every fluorine atom in the world is exactly the same. And then he also said that all matter is made up of atoms, which can't be divided into anything simpler. And both of those are basically true, except on the second one, we totally agree that all matter is made of atoms, but we found that there are particles that are smaller than an atom. So an atom could be divided if we needed to. So the definition that we work with today is that an atom is the smallest particle into which an element can be divided up and still be the same substance, or still be that element. So if we go past the atom, it's no longer that element. We're just looking at what we call subatomic particles, which are protons, neutrons, and electrons. We call them subatomic because they're smaller than an atom. Remember that Democritus and Aristotle and John Dalton, they all had these scientific theories. And over time, based on more evidence, since their scientific theories, they were able to change because we found a better explanation for why things happen. So if we look at the atom, first of all, an atom by itself is very small. In 1 penny, there's about, that's a really big number, that many atoms of copper and zinc inside of it. Now that's 3 billion more times, or 3 billion times more atoms in 1 penny than there are people on Earth. So that's a whole lot of atoms. They're very, very small. We can't really see them with a normal microscope. Within an atom, we have two major pieces. We have the nucleus and the electron cloud. The nucleus is in the middle, and that's where all of the mass from the atom comes from. And that's made up of protons and neutrons. That would be the red and green spheres over here. And then we have the electron cloud, which is all the space outside of the nucleus. And you guessed it, that's where the electrons live. And if we talk about those subatomic particles, a proton has a particular charge to it, and we call it +1. It's got a +1 charge. And it weighs very, very little in the grand scheme of things. Let's see, 0.00000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000subatomic mass units, which are really just relative masses. So instead of saying like 1.7 times 10 to the negative 40 or whatever grams, we say that a proton weighs 1 atomic mass unit. Relative to a proton, we have a neutron. It also weighs 1 atomic mass unit, so a proton and a neutron both weigh 1. But the difference is a proton's positive, protons are positive, remember that, and neutrons are neutral. So it doesn't have a charge. Its charge is 0. Which leads us to this joke over here. If a neutron was caught robbing a bank, would it be charged? And then we have electrons, which are totally different. They have a -1 charge, and they weigh so much tinier than a proton and a neutron that we basically just call them 0. They do have some mass, but relatively in the grand scheme of things, they're basically 0. So we say that a proton weighs 1, a neutron weighs 1, an electron weighs 0 AMUs, and protons are positive, neutrons are neutral, and electrons are negative. We can also look at atoms with a handful of nicknames. So instead of calling an atom, well, this atom has 12 protons and so many electrons and so many neutrons, because that would get tiring to say all those numbers every time we talk about it, we can use their atomic numbers and mass numbers. The atomic number is very simply the number of protons in the nucleus. So if you count up all the protons in one atom, that's that atom's atomic number. That's like the identity of that atom. And we'll learn later it happens to correlate with the atomic number on the periodic table, which tells you what name that element is. But for every atom, it's got a certain number of protons. There's no atom that doesn't have a proton. And that number is the atomic number. And then we have the mass number. Since protons and neutrons both weigh 1 and electrons weigh 0, then we add up all the protons and neutrons, and that gives us our mass number. That's different than the atomic mass you'll find on the periodic table, and we'll get into why that is later. But just remember, mass number is protons plus neutrons. And we could also talk about the charge, which is just if you add up all the positives for the protons and all the zeros for the neutrons and all the negatives for the electrons, your overall charge is what's left over after they cancel each other out. And we don't use electrons to help to name atoms because electrons they don't really stick around very much. They can be moved from atom to atom, or they could be moved farther or closer away to the nucleus. All sorts of things that electrons do that don't make them very good, stable indicators of what that atom is.